this video, we'll talk through the intermolecular forces topic from Higher Chemistry Unit 1. By the end of this video, you should be able to state different types of intermolecular forces, explain how the different types of intermolecular force arise, and also identify the strongest intermolecular force present in a given substance. First thing to know is that intermolecular forces are found between molecules. They're also known as van der Waals forces, and there's three types we need to know about: London dispersion forces, permanent dipole to permanent dipole interactions, and hydrogen bonding. You can be asked to pick the odd one out of a particular list of different types of bonds and forces. We're asked about van der Waals forces. These are our intermolecular forces, which are LDFs, permanent dipole to permanent dipole interactions, and hydrogen bonding. Covalent is an example of an intramolecular force, therefore it's the correct answer to this question. In terms of how London dispersion forces arise, these exist when we've got an uneven distribution of electrons within an atom, and this causes a temporary dipole. This means that we're going to have slightly negative and slightly positive parts of atoms. In our chlorine molecule, we have nonpolar covalent bonds, and then there's interactions between the different chlorine molecules, which are our London dispersion forces. The strength of these forces depends on how many electrons are present in a molecule, and they're going to increase with an increasing number of electrons. We're given 4 chemicals here and asked which of these contains covalent bonding and London dispersion forces. If we think of the structure and bonding of each of them, you can rule out neon and sodium because they've got monatomic and metallic structures respectively. To have London dispersion forces, we're looking for our covalent molecular molecule, which in this case would be sulfur. This question wants to know which of these will have the strongest London dispersion forces. We're going to relate that to an increasing number of electrons. When we look up how many electrons each of these have, argon at the moment has the highest number of electrons. However, we have got diatomic elements, which means we'll have twice the number of electrons present within them, making chlorine our correct answer to this question. When we look at permanent dipole to permanent dipole interactions, we are looking for chemicals which have a difference in electronegativity, which will result in a permanent dipole. When our hydrogen and our chlorine are joined together, the chlorine is going to have a slightly negative charge because it's got a higher electronegativity. And we've got our positive and our negative giving us our dipole. We can then have an attraction between neighbouring molecules, and this attraction would be termed a permanent dipole to permanent dipole interaction. Our hydrogen bonding happens in a very similar way to our permanent dipole to dipole interaction, except we're looking for a hydrogen bonded to a fluorine, oxygen, or nitrogen. And water would be a good example of this. We again have our polar covalent bond, giving us our permanent dipole. There's then an attraction between neighbouring water molecules, and this is termed as our hydrogen bonding. If there's hydrogen bonding present in a particular compound, it's going to be the most significant intermolecular force. If we can work out if a particular molecule is polar or nonpolar, we can determine the intermolecular forces present within it. We first want to look at if a chemical contains polar bonds or not, and then we're going to look at symmetry to tell us if it's a polar or non-polar molecule. We first look at something like water. Water has a difference in electronegativity between its two elements, therefore it contains polar bonds. We do not have a symmetrical shape, therefore we are going to have a polar molecule. In methane, we do not have polar bonds because we've got a very small difference in electronegativity, therefore we're going to have a non-polar molecule. Our trichloromethane does have polar bonds. It's not a symmetrical shape, therefore we're going to have a polar molecule. Our hydrogen fluoride contains polar bonds. It is not symmetrical, therefore it would be classed as a polar molecule. Our methanol contains polar bonds, is not symmetrical, again, a polar molecule. Our tetrachloromethane has polar bonds. It is symmetrical. The carbon is surrounded on all sides by chlorine. Therefore, we have a non-polar molecule. Once we have identified if we've got polar or non-polar, we're next going to think about the forces of attraction within them. If we have non-polar molecules, we're going to have London dispersion forces as the strongest force within it. If the chemical contains hydrogen bonded to fluorine, oxygen, or nitrogen, we're going to have hydrogen bonding as our strongest force, which we have for water, hydrogen fluoride, and methanol. Whereas for our trichloromethane, we've got permanent dipole to permanent dipole interactions. This table tries to sum up all the different things you need to take into account in terms of polar and non-polar bonds and polar and non-polar molecules. In terms of questions, this one tells us that each of these has got a polar bond because there's a difference in electronegativity between the atoms, and it asks us to figure out which of these, therefore, is a non-polar molecule. We're looking for a symmetrical molecule, and our carbon dioxide has a carbon with oxygen on both sides of it, therefore it will be a non-polar molecule. In this type of question, we were given a particular chemical and asked about the type of intermolecular force present within it. We've got polar bonds because we've got a difference in electronegativity. It's non-symmetrical, and therefore it's a polar molecule. The strongest force will be permanent dipole to permanent dipole interactions. It's not hydrogen bonding because it's not fluorine, oxygen, or nitrogen connected to the hydrogen. And permanent dipole to permanent dipole interactions occur when we have a difference in electronegativity, leading to permanent dipoles or polar covalent bonds. Hopefully, you're now able to state the three different types of intermolecular forces, explaining how the different types of intermolecular force arise, and also be able to identify the strongest intermolecular force present in a given substance. Thank you for watching. Goodbye.